Okay, ma? So next topic which we are studying is transistor. See, in PN junction diode, there is only one junction. No, ma? This is P, this is N, and here we had only one junction. Clear? But in transistor, what we do is we place an N type between two P's, or we place one P between two N's. Both are transistors only. Clear? So obviously you can find two junctions are present. No? So here there is one junction, here there is another junction. So already we studied that N type, it loses electrons, no? So it will gain positive charges, positive side. P type, it loses holes, no? So it will gain negative charge. So therefore this is the direction of electric field at the first junction in PNP transistor. Clear, Nama? Similarly, here what happens, N type, again it loses electrons, so it will gain positive charge on this side. And this is P type, no? So this loses holes, so it will gain negative charge on the other side. So definitely this is the direction of electric field in the second junction. So in the first junction and the second junction, electric fields are in opposite direction. Clear, Nama? Now same concept with the NPN transistor also. This is the direction of electric field at first junction. This is the direction of electric field at the second junction. Okay. Now out of them, one is called an emitter, second one is called a base, and third one is called as a collector. Clear, Nama? See here, these are the respective sizes. Ma. Emitter is moderate, average sized. Base is very small, whereas size of the collector will be very big. Clear? And whatever it may be, whether it is an NPN or PNP, emitter, base, collector, always they remain same. Okay? And emitter is very highly doped. Size is medium, but doping levels are very high. Okay? Base, it is very small and doping is also very small. Very small and lightly doped. Clear? Whereas if you take collector size is very big, but doping is average, medium dope. So questions can be asked on the amount of doping and size also. Are you able to understand? So, why this one is called as emitter? Because it always gives the charge carriers. And why this one is called as collector? It always receives the charge carriers given by the emitter. Are you able to understand? Ma? So this is emitter, gives the charge carriers. And the charge carriers given by emitter, where only very few, for example 5% of the charge carriers, they combine with the charge carriers in N type, and remaining 95% they travel to the collector. Are you able to understand? So that is why it is called emitter, base and collector. So you make a note here also. So 5% of charge carriers combine with charge carriers in the sense electrons or holes, ma. Combined with charge carriers in base, and 95% reach the collector. Okay, ma? 95% of them they reach the collector. This is one point which you should remember. Okay? Right. Okay, see, ma. So next we will discuss about biasing of transistor. See, ma, there are two junctions. No, this is my first junction and this is my second junction. So in the case of transistor, emitter base junction. Emitter base junction means which junction? This junction, J1, first junction. So this junction should be always forward biased. Are you able to understand? And this is my second junction, no? Second junction J2. And this is which junction? This is collector base junction. Emitter base junction, collector base junction. Emitter base junction should be always forward biased, and collector base junction should be always reversed biased. This condition always you should remember. Clear, ma? Now because two types of transistors are possible, NPN is also a transistor, PNP is also a transistor. Now if I talk about NPN transistor, are you able to understand, ma? So how to connect this junction in forward bias? What is meant by forward bias? Forward bias ka to? Electric field should cancel. Very good. Any other method of simply explaining? Inka? Electric field should get cancelled. No? That is called as forward biased condition. Any other method of explaining? Sima. Negative connected to negative, positive connected to positive. That is forward biased condition. Poddane kada class lo cheppindi. negative connected to negative terminal of the battery is called forward biased condition. Are you able to understand? Now see here, because negative is connected here, what will be the direction of electric field because of this battery? Direction of electric field will be in this direction. So this is E external. This is the external electric field because of this battery. So this field and this field, they will get cancelled with each other. So definitely it is in forward biased condition. Reversed bias condition means what? Negative connected to positive terminal of the battery. Are you able to understand? So if this is the direction of battery positive, then this is the direction of electric field. No? E external will be in this direction. So both electric fields are in same direction. So it is forward biased or reversed bias? Definitely reversed bias condition. If electric fields are getting cancelled, it is forward biased. Electric fields are helping each other, then it is reversed bias condition. So first junction is forward biased, second junction is reversed bias in the case of a transistor. Okay, same concept here also. Clear now? Now this was NPN, no? This is PNP. Now here how can I connect to this battery? This is emitter base potential. EB means what? Emitter base potential. CB means collector base potential. Okay. Now positive connected to positive. So definitely forward biased. Okay, ma? Positive connected to negative. Definitely reverse bias. Like this you can remember. Okay. Right now. Okay. Now see now. So we will now study actually how this transistor is working, based on which logic it is working. See ma'am. For example, if I take NPN transistor, same operation you can study with PNP also. Everything is same. Huh? If I take NPN transistor, this emitter base junction is forward biased. No? So if it is forward biased, what happens? So here it is negative terminal, here it is positive terminal. So this negative terminal of the battery, it will force the electrons out of the emitter. No? Because here negative side terminal is applied, on the other side positive terminal is present. Are you able to understand? Ma? So this negative terminal, because it is forward biased, it will push the electrons through the base. Electrons ఏం చేస్తుంది potential, it will push the electrons towards the base. And what is the nature of the base? Base is lightly doped. No? Base is what kind of base? Lightly doped. So, and here what is the kind of material we have taken? P-type. P-type means what? The majority charge carriers, holes. So some of the electrons, they combine with the holes. Here you are seeing one hole, no? So they combine with the holes. And when they combine, we get a new type of current which is called as base current. Are you able to understand? Ma? So base current is produced in which condition? When the majority carriers in emitter combine with the majority carriers in base, then base current will be constituted. And already we studied that how much percent of emitter current, emitter electrons will combine with base? Only 5%. Remaining 95% they enter into the collector. Are you able to understand? Ma? So therefore, this constitutes another current which is called as collector current. So electrons are moving in this direction, no? So current is in which direction? Current should be in opposite direction. No? Already we have studied. No? What is the direction of current? Conventional direction of current. Flow of positive charges. Flow of positive charges is taken as direction of current. Flow of electrons kaadu. If electrons are moving in one direction, it means positive charges are moving in opposite direction. So therefore, okay ma? So if this is the direction of electrons, this is the direction of current. Okay? So this is emitter current. This is base current and this is collector current. But electrons are moving exactly in opposite direction. Are you able to understand? So this is called transistor action. And definitely we can understand this point, no? Total emitter current is the sum of collector current plus base current. This current is also produced because of emitter. This current is also produced because of emitter. So IE is equals to IC plus IB in whatever may be the type of transistor, whether it is NPN or PN. If it is PNP, then how can I draw the diagram? Electrons kaadu. Holes will move. Clear ma? This is N no? Here majority carriers are electrons. But if I place P here, then majority carriers are holes. Holes start moving in this direction. It means current is also in the same direction. Direction of holes is nothing but direction of current. So can you draw the same type of diagram for P and P? Huh? Try change. And one more point ma here, see ma. This first junction is forward biased, no? First junction is forward biased. Because it is forward biased, its resistance is very less. Forward biased లో రెసిస్టెన్స్ ఏముంటుంది, కొంచెం పొటెన్షియల్ మీరు సప్లై చేస్తే కండక్షన్ అది స్టార్ట్ చేస్తుంది. సో ఇన్ ఫార్వర్డ్ బయాస్డ్ కండిషన్, దట్ ఈస్ అట్ ద ఫస్ట్ జంక్షన్, ఎమిటర్ బేస్ జంక్షన్, ఇన్పుట్ రెసిస్టెన్స్ ఈస్ వెరీ లెస్. సో ఇన్ ట్రాన్సిస్టర్ ఇన్పుట్ రెసిస్టెన్స్ ఈస్ వెరీ లెస్. బట్ ఇన్ ద కేస్ ఆఫ్ సిబి జంక్షన్, సిబి అంటే చికెన్ బిర్యానీ కాదు, కలెక్టర్ బేస్ జంక్షన్ ఇది. హోటల్ పోతారు ఒక సిబి అంటారు చూడండి, అట్లా సిబి కాదు ఇది, కలెక్టర్ బేస్ జంక్షన్. అట్ కలెక్టర్ బేస్ జంక్షన్ రివర్స్డ్ బయాస్ నమా. So therefore output resistance will be very large. Are you able to understand? So this is the reason actually why transistor behaves like an amplifier. It means if you give this much of signal, adi inta pedda signal ay bayitiki vastundi. Okay, this microphone is an example of a transistor. Are you able to understand? So here you give very small signal that converts into a very big signal. Are you able to understand, ma? So therefore input junction is always having less resistance. Output junction, that is second junction, always has very high resistance. Okay, so this is the reason why it behaves like an amplifier. Fine, right? Sima. So now we are studying about transistor can be connected in how many configurations, ma? See here, for input we require 2 terminals, ma, and for output also we require 2 terminals. So totally how many terminals are required? 4 terminals are required. But problem is that we have only 3 terminals. One connected to emitter, second one connected to base, third one connected to collector. So therefore what I can do is, I will make one terminal common to both input as well as output. Clear ma? For example, if I take this terminal, I will make it to common to emitter also, I will make it common to collector also. So that 3 terminals are converted into 4 terminals. That is the principle of transistor circuit configuration. So based on that, we get 3 configurations. Which one we are making common? So common base configuration means what? Base is common to input and output. Common emitter means emitter is common to both input and output. Common collector means what? Collector is common to both input and output. So 3 configurations we have. And these are the symbols of the, and C is the most used configuration. Okay, so questions also you will get mostly from these 2 topics only, common base and common emitter. These 2 configurations you will get. We will draw those configurations, but before that we forgot to study the symbol of transistors. PNP transistor, this is the symbol. P supplies holes, no? P supplies what? Holes. Holes direction is the current direction, no? So from P to N, this symbol you have to draw. If you are writing this kind of symbol, it indicates it is a PNP transistor. This symbol enduku vesnam ila? Because current always flows from P to N. Holes direction is current direction, no? That's all. Similarly, NPN transistor, from N to P electrons will travel. From N to P what will travel? Electrons will travel. So current flows in which direction? Again P to N. Again current flows from P to N only, so P to N. So if you draw this direction of what you call current, then it means that it is an NPN transistor. This is how you have to remember. Okay, right? Okay, see ma. So first configuration which we are studying is common base configuration. What is meant by common base configuration? Base is common to input also, base is common to output also. This is the base, no? This is common to input. Same base terminal is common to output also. And this is what kind of transistor? NPN transistor, and this is the symbol of NPN transistor, no? Clear? So definitely this is the direction of emitter current, base current, collector current. So this emitter current, after reaching up to here, it splits up into 2 currents, base current as well as collector current. So first junction forward biased, second junction is in reversed bias. So this is N, no? N connected to N, forward biased. Okay, ba? This is also N, no? N connected to positive terminal, reversed bias condition. Are you able to understand, ma? Okay. Now, in this common base configurations, questions can be asked on input and output characteristics. So what is meant by input characteristics? We draw the graph between emitter current and first junction potential. Okay, ma? It means if I rise VEB, what is VEB? the junction, the potential which is applied to first junction J1. Okay, this potential if I rise, then I will find out how IE, emitter current, how it varies. That I will draw a graph. And in the output characteristics, second junction is present, that voltage is taken to be constant. So in drawing throughout this graph, VCB is taken constant. Are you able to understand what is VCB? Collector base junction. Potential applied to collector base junction, that is a constant. Are you able to understand? So therefore this is the graph which I get. So what do you understand by this graph? ఆ గ్రాఫ్ చూస్తే ఏమర్థమవుతుంది? మరి అంతే కదా. If I increase VCB, that is if I increase the potential, if I increase the forward biased potential, emitter current also increases. Okay, and if VCB increases, if VCB, that is second junction potential, if it increases, then also IE value further increases. Are you able to understand? So these are the input characteristics. So first junction potential you increase, emitter current also increases. Are you able to understand? Now see the output characteristics. So in output characteristics, we take output current. Which is the output current? IC is the output current. And we will change the second junction potential. Which is the second junction potential? VCB. Okay, ma? And in every graph, IE is taken constant. So in the first graph, IE is 1. IE means emitter current. Emitter current is considered constant. And throughout the second graph, again IE is a constant. Throughout the third graph, IE is a constant. Are you able to understand, ma? Okay. Now by looking at these graphs, what do you understand? अच्छा देखो, घूर को देखो. So IC is remaining a constant, no? See, if you take the first graph, IC value is increasing only up to certain level. After that, it is not increasing, it is a constant. But if you increase IE value, then it increases up to some more level, then again it is becoming a constant. What can be the reason? So even you increase output voltage VCB, output current is not increasing. అదే కదా ఇక్కడ అర్థమయ్యేది. Output voltage you are increasing, current should increase, no? But current is not increasing. ఎందుకంటారు అలా? What can be the reason? We are not discussing about VEB. We are discussing about VCB, output voltage, collector base voltage, and output current. Okay, ma? In every condition, IE is made a constant. So IC increases only up to certain level. After that, it is not increasing. What can be the reason? Load to నీకేం పని? ఎవరు కన్జ్యూమ్ చేస్తారు? वो कंज्यूम होना है तो करंट आना नहीं कैसे? ये कहीं को इंक्रीज होता नहीं बोलो. एनी आइडिया? అయితే see, my reason is that already we have written equation, no? IE is equals to IC plus IB. This already we have written, no? IC depends on what? IC దేనిపైన డిపెండ్ అవుతుంది? IE పైన. IE కాన్స్టెంట్గా ఉంటే IC మాత్రం ఎట్ట పెరుగుతుంది? ఏం తెలివితేటలా అనేవి వేరే పాసిబుల్. ఈ ఈక్వేషన్ చూడలేదా మీరు? ఐసీ దేనిపైన డిపెండ్ అవుతుంది? ఐసీ డిపెండ్స్ ఆన్ వాట్? ఐఈ. యు ఆర్ మేకింగ్ ఐఈ కాన్స్టెంట్, దెన్ హౌ ఐసీ కెన్ ఇంక్రీజ్ అవ్వదు అనమాట. మీరు హైట్ అంతే ఉన్నారనమాట, పట్టి లాగినా పెరగరు ఇంకా, ఎందుకంటే పెరిగే వయసు కాదు కాబట్టి. ఇది కూడా అంతే. ఇది కాన్స్టెంట్ పెడితే ఇది ఎట్లా పెరుగుతుంది? పాసిబుల్ కాదు. సో దట్ ఈస్ ద అవుట్పుట్ గ్రాఫ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సో వాట్ ఎవర్ మే బి ద VCB వాల్యూ, ఇది ఎంత ఉన్నా దాని మనకు అవసరం లేదు కదా. Everything depends on what? Everything depends on IE value. If IE increases, IC also increases up to level. But if you are taking IE constant in every graph, then IC you cannot expect to increase. Okay? But it increases up to certain level, no? కొంచెం వరకు పెరుగుతుంది. ఎందుకు? మిగిలిపోయినట్టు కొన్ని ఎలక్ట్రాన్స్ హోల్స్ ఉంటాయి కదా, ఆ కొన్ని లాగేసుకుంటుంది, ఆ తర్వాత మర్యాద కూర్చొని ఉంటుంది అన్న. ఇట్ కెనాట్ ఇంక్రీజ్. దట్ ఈస్ ద మీనింగ్ ఆఫ్ ఇట్. ఓకే, రైట్. ఓకే, సిమా. So these are the different gains, different gains in common base configuration. Okay, See, first one, current gain. Current gain we will study two types. One is AC current gain, second one is a DC current gain. So, output current by input current, that's all. That is called as current gain. Are you able to understand? What is the output current? Collector current is the output current. Which is the input current? Emitter current. So, IC divided by IE is called as alpha DC or DC current gain. AC current gain means a change in these values. These are absolute values. When you take a change in those values, that is, what is the change in IC for a change in IE? IE mariste IC anta marutundi. That is called as AC current gain. Are you able to understand? So delta IC divided by delta IE, and this is always a constant. VCB should be kept constant. Output potential should be kept constant. Clear now? Similarly, voltage gain. So for changing the input voltage, what is the change in output voltage? That is called as voltage gain. Okay. So here who is the input? VEB. Who is the output? VCB. So change of these two is called as voltage gain. And V can be written as I into R, no ma? V, how I can write? I into R. So V can be written as I. These are output values, no? So VCB, how can I write? IC multiplied by R output. Are you able to understand? So delta IC multiplied by output resistance is R0. So delta IC multiplied by R0. And this is input voltage, no? So input current multiplied by input resistance. Okay. So voltage gain can also be written as delta IC R0 divided by delta IE into R input. Delta IC by delta IE already we have written alpha, no? So alpha multiplied by R0 by R input. So this is output, this is input. And output resistance by input resistance is called resistance gain. Current gain, voltage gain, resistance gain. So therefore, this is another very important equation to calculate voltage gain. So voltage gain is alpha AC multiplied by resistance gain. And what is alpha AC? Change in output current divided by change in input current. Clear, Nama? Similarly, power gain. Power is V into I. Know what is power formula? V into I. So output power divided by input power. Output power voltage is VCB, output current is IC. Input voltage is VEB, input current is VIE. Okay. IC by IE, again alpha, no? So alpha into, and delta VC by delta VEB is nothing but voltage gain, no? So therefore I can write alpha AC multiplied by voltage gain. And voltage gain can again be written in this format, no? Okay, ma? So voltage gain can also be written as alpha AC multiplied by R0 by Ri. So that value again I am writing here. So therefore alpha into alpha, alpha square multiplied by resistance gain. So this is the equation for power gain. So how many gains we are discussing? Current gain, voltage gain, resistance gain, power gain. Are you able to understand, ma? And voltage gain is very large, ma. You give a small input signal of voltage, you will get a very big output. What is the reason? Reason is very simple. Resistance gain, R0 by R input. Output resistance is very large, no? Already we discussed which resistance is very large in transistor. Output resistance is very large. So when compared to output, input resistance is very small. So automatically voltage, output voltage also will be very large. So therefore transistor works as an amplifier. Okay, ma? Speakers, మాట్లాడతారు కదా, speakers, they are amplifiers. So మీరు మెల్లుగా మాట్లాడితే అది గట్టిగా అనిపిస్తుంది. Reason is this one. Are you able to understand? Right. Now see. So now we are studying about the second type of configuration, which is called as common emitter. See here, emitter is connected common to input and output. Clear? Emitter is common to input also, emitter is common to output also. So this is an NPN transistor. So therefore these are the directions of the current. I did not explain the directions of current, no? I hope you can understand. Clear, ma? Now see. Now here who is the input current? IB is the input current. IC is the output current. So therefore input characteristics should be drawn between input voltage and input current. Input current is IB, input voltage is VEB. Same type of graph. As you increase VEB, IB also increases. And same type of output characteristics also. Output characters between output current is IC, output voltage is VC. But here IB is kept constant. Previously IE was kept constant, no, now IB is kept constant. So if IB value does not change, IC also does not increase. Are you able to understand? Because if input current doesn't increase, output current also does not increase. Are you able to understand? Now these are the gains, different gains. Again, current gain, voltage gain, resistance gain and power gain. Same concepts. Just values will change, that's it. Okay? See, in a common base configuration, we use alpha for current gain. Okay? In a common emitter configuration, we use beta for current gain. Remember these points. Alpha is the current gain in common base. Beta is the current gain in common emitter configuration. Now see. So same concept. My DC current gain is what? IC, output current by input current. Change in output current by change in input current. And voltage gain is nothing but output voltage by input voltage. Voltage can be written as I into R. So again same concept. Beta AC multiplied by resistance gain. That is voltage gain. Okay. Next, power gain. Power is nothing but V into I, no? So output power divided by input power. Output power means output voltage, output current, input voltage, input current. That's it. Clear, ma? And voltage can be written as again I into R, no? Voltage already we have written beta AC into resistance gain. So substitute here. So beta into beta AC multiplied by resistance gain. So beta AC whole square multiplied by resistance gain is the equation for power gain. Okay? Very simple, ma. Just so these are the different relations between alpha and beta. Clear? What is beta? Beta is the current gain in CE configuration. Alpha is the current gain in CB configuration. So beta is equals to alpha by 1 minus alpha, or you can write alpha is equals to beta by 1 plus beta. These are the two relations. Okay, anyone you can use. Sima. This is one question. In CB configuration, CB means common base number. Immediately, this is the diagram which you should draw. Clear, no? So, for example, if it is an what type of transistor, he did not give. I will take it as a PNP transistor. So, this is P, this is N, this is P. So, this is emitter, this is base, and this one is collector. So, definitely, this is IE, input current. This is IC, output current. That's all, no? So first if you draw the configuration, then you will understand which one is input, which one is out. Common base, no? Input will be IE. Output will be IC. Now see. So common base configuration, current amplification factor alpha is equals to 0.9. Okay? And what is alpha? IC divided by IE, output by input. Clear, no? And the emitter current already he gave. So he is asking the base current. IB I want to calculate. Clear, Nama? So therefore do this calculation. Emitter current is given. So IC is equals to IE multiplied by 0.9. IE is 1. 1 multiplied by 0.9 is how much? 0.9 milliampere. Clear, Nama? So this is IC value. But that is not what he is asking, no? He is asking IB value. How can I calculate? That relation already we have, no? IE is equals to IC plus IB. This is satisfied in any type of transistor. Everywhere it is satisfied. Clear? So IE value? IE1. IC? 0.9 plus IB. ఇట్లా చేసినావు కొంపదీసి నువ్వు నిజం చెప్పు. ఓకే. So IB is equals to 1 minus 0.9. It is 0.1 ampere. That is our answer. Okay.